Modern science arose despite the prevalence of superstition, such as those wrong ideas by the ancient Greeks, and it largely arose because of the Judeo-Christian worldview. For instance, Aristotle, of the 4th century BCE, taught that the processes of decay only happen on the earth, and believed that the heavens above and the things in it were eternal and unchanging, without decay. This dogma prevailed for many centuries, until the 18th century when scientists formulated the concept of entropy, which suggests that all matter, whether on Earth or in the heavens, has a tendency to decay. Lord Kelvin was one of those early scientists who helped to advance this concept. He noted what the Bible says about heaven and earth: just like a garment they will all wear out. Psalm 102, verse 25 and 26. However, Kelvin also took note that the Bible also taught that God's will was for the earth to remain forever, Ecclesiastes 1:4, that God has decided to prevent such deterioration from destroying his creations. Psalm 102, verse 26 says, "They will perish, but you will remain, just like a garment they will all wear out, just like clothing God will replace them, and they will pass away." But some materialist atheists were still holding to a past eternal steady-state universe, until it was debunked by other further scientific discoveries, when Einstein's theory of relativity and astronomical observations suggested that the universe was expanding, thus implying a beginning point of time and space, and this was further confirmed by the discovery of the cosmic microwave background radiation. Thus, to the chagrin of materialist atheists, the universe requires an explanation for its existence. And, for materialists, the problems only kept getting worse from there. Regarding Richard Feynman's 1964 lecture on the distinction of past and future, it's interesting how Feynman refutes this sometimes mythical conflict between science and religion. Even when using God as a religious metaphor, studying one aspect of the universe alone is not going to get you necessarily nearer to God than what another aspect might be able to do, not without taking the big, complex picture into account, that is, with many aspects of the world altogether, many interconnected hierarchies of complexity. In a similar way, neither observing only two molecules colliding will ever distinguish the direction of time's arrow. Not with that aspect alone, you need to zoom out and look at the total effect, the bigger picture of what is going on, with billions and billions of atoms jiggling and bouncing, and it is only then, at least at the level of immediate human perception, closer to the macroscopic level, is when you begin to get a clear distinction of time's arrow. It is only from distinguishing the direction in physical change, which is always from order to disorder, but only at a larger part of the whole system, is when you begin to get at least a partial understanding of it, that the particular fundamental basis of it is the laws of probability and statistical mechanics. The entropy phenomenon gives us an empirical handle on the remote past in the same way the apparent expansion of our universe is claimed to do. In more recent times we know that if we backward extrapolate in time and infer that the universe of the past was more densely compacted, inferred from the redshifts of galaxies, the apparent brightness of standard candles, such as Cepheid variables, and how their pulsation period is directly related to their intrinsic luminosity, the redshifts of 1A-type supernovae and their apparent brightness, and so on. This not only infers their distance but is believed to indicate how far back into the past we are observing them, and we can also independently observe and measure from the entropy principle. Everything we know of is increasingly becoming more disorganized, and we might therefore logically infer, from these separate lines of investigation, that in the past such things had a beginning. And they began in a state of maximum order, the inference of which is due to the observed direction and rate of decay, just as we observed the way things happen right now, and will continue to happen, for as long as the universe exists in an out-of-equilibrium state. Scientists tried to determine the age of many other things by their rate of decay, and this same type of reasoning can be applied to the entire universe as well. The scientific question can rightfully be asked: what, or who, in the beginning, created a more ordered universe? A question that naturalistic science possibly cannot answer, and where science might stop, and where philosophy and theology might continue on. Paradoxically, this natural law, the second law of thermodynamics, is emergent from the other laws built into the universe, and also nonetheless fundamental but in a different way to other natural laws. It seems to be statistical, and purely informational, and asymmetrical, irreversible. There is a one-way characteristic to it. So at the macroscopic level, much of which we experience in our everyday life, entropy is described as the second law of thermodynamics in terms of differences in pressure, temperature, density, color, height or levels, and so forth, on average trying to mix and equalize and become more uniformly distributed, and the rate at which this decay, or loss of potential flow, or loss of usable energy, is happening. At the fundamental level, the submicroscopic level, the cause of such phenomena is described in terms of the random perpetual motion of particles jiggling and bouncing and statistically tending toward randomness and disorganization, becoming evenly mixed. The overall result is that a closed isolated system runs out of potential energy. From a materialist perspective, one that is absent of any affirmative theology, in physics the universe is considered to be a closed system. Feynman's thought experiment involving the ratchet and vane cannot happen in real life because it would take vastly more than just 2 or 3 molecules to move the pole a distance of one tooth, and even if in a scenario where turbulent wind currents occasionally move the wheel in either direction, the probability of the pole coming back down on a tooth as an inclined plane is very low. But most prominently is the fact that such a pole would not jiggle at the macroscopic level as described when heated, but if anything at all might melt if hot enough. The jiggling of the atoms would be the heat of the object itself, and, above a certain temperature threshold, the atom's jiggling is also the observed macroscopic phenomenon of melting. So obviously his thought experiment should not be taken too literally. It is oversimplistically analogizing the irreversible phenomena of nature to highlight a principle. Similar too, is for his wet towels analogy, because evaporation was not factored in. It is analogy that excludes extra variables for reductionist simplicity, in order to easily understand the more fundamental concept, that an out-of-equilibrium condition is needed, for energy to be available, for it to do something useful. Feynman acknowledged the very mysterious level in the entropy phenomenon, even when studying and calculating the trajectory of the individual particles in a reduced theoretical system. In reverse time their trajectories still compute, and yet this outcome does not happen on the larger scale, the big picture of things. Things in reality do not become less random and separated in this way, and yet each individual molecular collision, when the movie of it is reversed, is still okay. This is one of those conundrums that almost seems to defy human reasoning ability. The fundamental solution to partially understanding this is to consider possibility spaces, the laws of probability, within systems of organization, and calculate how many possible states there are of disorganization as compared to possible organized states of being, within the same possibility space, and thus try to calculate the ridiculously low probability of the organized arrangement therein never happening. In this case the organized state is very simple compared to some other known systems. It is just a lopsided separated mass of 2 different liquids, and yet despite this, the chances of them separating by themselves are indistinguishable from 0. This provides a partial understanding of why things will go one way overwhelmingly most of the time bar one highly improbable organized condition, which, due to chance, in most cases is practically impossible given the limited age of the universe, and that is even in a relatively simple system of molecules bouncing around, without any mechanistic integrated complexities like what are found in biological systems, which under those circumstances of irreducible complex functionality, seem not only improbable, but impossible. Feynman used a form of hyperbole by deliberately understating it, by saying that it would never happen in a million years, because, in theory, incomprehensibly more time would be needed. This is also a critical issue with biology and Darwinian evolution, since genetic science has uncovered the copying mistakes that happen within DNA code, and not all those errors are corrected but instead passed on to the next generation and so forth. So it's no real logical leap to assume that entropy will be increasing over time and over successive generations in the biological phenomena of the world as well. And if that is all what exists, for nature to select, then, without miraculous intervention, it appears most certainly doomed. Non-reductive physicalism is the view that all entities and properties in the world are fundamentally physical, yet higher-level properties, especially mental states like consciousness, cannot be reduced to, or identified with, basic physical laws or particles. While Feynman was a physicist and not a theologian nor a philosopher of mind, his argument provides the scientific scaffolding that non-reductive physicalists use to explain how complex phenomena, like consciousness or divine action, can exist in a world governed by simple physics. Some might imagine that this might lend weight to the compatibilist view, the view that free will and determinism are compatible, arguing that individuals can be free and morally responsible even if their actions are determined by prior causes. So, remorse, regret, and hope, and so forth, are words that very obviously distinguish past and future. Others, who reject compatibilism, still argue that it's all fully deterministic, and that there are still serious consequences for criminal behavior due to cause and effect, therefore responsibility is not diminished more than in the compatibilist worldview. So, it appears that if some people make the argument that determinism might be used as an excuse for evading legal responsibility, they would be wrong, because within either worldview there are always physical consequences for whatever actions have been initiated. Feynman did not support the steady-state theory. By the time he delivered the Messenger Lectures at Cornell in 1964, which became the book The Character of Physical Law, the scientific tide had turned decisively toward the Big Bang, evolutionary, model. When Feynman was speaking in 1964, the steady-state model, championed by Fred Hoyle, was in its death throes. That very same year, Penzias and Wilson discovered the cosmic microwave background radiation, which was said to be the smoking gun for the Big Bang. Feynman's entire argument regarding the arrow of time relies on the universe having an ordered beginning, a boundary condition. In physics, a boundary condition, or initial condition, is a set of information that is not contained within the laws of nature themselves, but is necessary to get a specific result from those laws. If you look at the equations for two atoms colliding, the equations work perfectly fine forward and backward. There is no direction in the law. Therefore, the reason our world has a direction, going from order to disorder, must be a boundary condition. You might think of it this way: the laws tell you how things change. The boundary conditions tell you where things started, but they don't tell you why. The Big Bang requirement, for the second law of thermodynamics, entropy increasing, to work as we see it, the universe must have started in a state of extremely low entropy. Physics cannot account for this ordered start, so this is the boundary where a physical explanation is not possible, where science can go no further, where materialists can engage in only metaphysical speculation, if they can be bothered. So the steady-state idea has a problem. If the universe were eternal and unchanging, steady state, it would be difficult to explain why we haven't reached a state of heat death or total equilibrium already. The only reason we can distinguish the difference between the past and the future is that we exist in the aftermath of a vast, organized event. Feynman leaned toward the Big Bang because the physics of entropy demanded a starting point of order, yet he was characteristically cautious. He didn't like dogma. But, he viewed the steady-state model as increasingly inconsistent with the asymmetry he was observing in the laws of thermodynamics. This is where the scope of naturalistic science reaches its limitations. How can there be such order? The boundary condition. So, Feynman, as flawed as he was, like all humans are, nonetheless made a great contribution to science in helping us understand the character of physical law. He acknowledged, it is necessary to add to the physical laws the hypothesis that in the past the universe was more ordered than it is today. And that statement has profound implications. Theologians argue that while science explains the laws of physics, it cannot explain why the universe was set up in such a highly improbable, ordered way to begin with. The universe needed a very specific kind of Big Bang. Secular cosmologists also understand the problem. Roger Penrose, who is not a theologian, building on the logic Feynman discusses, famously estimated that the aim of the Creator, or the precision of the initial conditions, to produce our low-entropy universe would need to be accurate to 1 part in 10 to the power 10 to the power 123. This degree of order is so vastly precise, it is unfathomable. So you can see why it is called a boundary condition. It is hard to imagine how science can go any further beyond this point, without engaging in metaphysical speculation, as some are doing. To a theologian, this looks like divine providence encoded into the very first nanosecond of the universe, theoretically somewhere from t equals 0 to before 10 to the power minus 43 seconds of physical existence. When you connect fine-tuning to boundary conditions, you are essentially asking if the universe started with a massive injection of specified information. The initial boundary conditions of the Big Bang weren't just low entropy, ordered, they were specifically ordered to allow for stars, chemistry, and eventually, observers. If the expansion rate or the jiggle, as Feynman calls it, were off by a tiniest fraction, the universe would be dead, either a black hole or a thin gas at most, or, if protons can decay, perhaps just leftover radiation. Theologians argue, as do physicists, that laws are mindless descriptions of what happens next, but it seems that information is a product of mind. Increasing entropy is the natural undoing of what a mind has organized, and the second law of thermodynamics seems like an emergent consequence of what was originally organized. We are thus led to a more profound question: can the code of DNA emerge purely from the laws of physics, or does it require a new boundary condition or input of information? When we scientifically talk about evolution, what we are really talking about is the naturally progressive undoing of the initial conditions, whatever they might have been. Atoms jiggling according to laws, like gravity or electromagnetism, don't naturally form sequences that represent something else. The laws, physics and chemistry, these explain how a carbon atom bonds to a nitrogen atom and so on. They are law-like, and repetitive, like crystals. The seemingly insurmountable difficulty for the materialist is the code in DNA. This is a specified sequence, like the letters in a book. The meaning, the protein it builds, and other sophisticated runtime code sequences, isn't determined by the attractive or repulsive forces on the base pairs within the DNA, like the chemistry of the ink of a book, but by the order of the letters, the order of the base pairs, that speak. So, is life a new boundary condition? Some theologians, and information theory proponents, argue that the origin of life represents a second Big Bang of information. Is it the spoken word of God perhaps? Is this question only a religious metaphor? It looks highly unlikely. If any sequence is chemically possible, then the specific sequence that creates a functional cell is statistically miraculous, and that scarcely begins to explain the scope of the entire problem. It's vastly even more difficult than that. So, the entropy law is a law of irreversible phenomena. It goes one way through time, and many believe it even defines the one-way direction of time itself, and gives the concept of time meaning to the operation of the human brain. Some go even further and say that time is just an illusion, an abstract notion born of the human mind from the one-way direction of change in the relative movements of many particles interacting. The physical principles which the workings of the human brain and the human senses also seem to operate within, and rely on, for their motion and ongoing functional dynamic, but, Because of being embedded in this space-time framework, it is then difficult for the human intellect to think up concepts outside of it. Physics urges us to face the cold hard reality of things. Everything in the universe decays over time. Even functional information becomes more degraded over time and more scrambled. Everything, every hierarchy of complexity, eventually becomes more disorganized, more random, more mixed up, completely scrambled, and more uniformly distributed over time, because of the laws of probability that determine the outcome of all particles in motion jiggling and bouncing. And there is no escaping it, not for any of us, for we are all subject to it. In human terms, there is no way of defeating entropy. Sooner or later, without a divine miracle, without a savior, whether you believe it possible or not, no matter what we try and do to delay it, entropy always wins, in the end. Degradation and disorder of one kind or another affect us all over time, and it seems that it would be miraculous if we never died at all. We are at present doomed, due to the chaos of irregular perpetual motions, of the particles, of which we are made. It is very humbling to contemplate. Increasing entropy, until a maximum amount is reached, within the system, at every level of reality, so far observed, has always proven to be inevitable. This is the uniform and repeated experience in all of physics in the laboratory, and everywhere else observed in nature. And most significantly, from a scientific perspective, it has been tested many times, and never falsified. Even though the argument has always been open to attempted falsification and rigorous testing, it remains unfalsified, both at the experimental and theoretical level. Entropy has been categorized by various people into different types, for example, Boltzmann entropy, information theoretical, Shannon entropy, quantum entropy, and entanglement entropy, decoherence. Thermodynamic entropy, macro entropy, organizational entropy, genetic entropy, and so on, may be all the different hierarchies of complexity that you can possibly imagine. All types of entropy without exception are subject to both physical laws and statistical probabilities. All things known to physics and information theory, everything involving matter and motion, and information. It is open to both empirical testing and theoretical investigation, and therefore, the statistical mechanics of it all is one of the most scientifically and mathematically established arguments of all time. There are, from this inconvenient truth, dire implications for the type of Darwinian philosophy that appeals to materialist evolutionism, because if the genetic code is a very specified language, as science is surely beginning to reveal, then it would seem that the materialist evolutionist emotionally clings to a hopeless idea that some unknown natural mechanism, perhaps using natural selection, might overcome entropy locally, and permit an imagined localized upward Darwinian evolution to be possible. Whereas it seems the creationist has accepted the cold hard scientific facts of thermodynamics and its statistical improbabilities, and is therefore convinced that upward Darwinian evolution, macroevolution, is just a myth, and nothing more. And so, whether there is confirmation bias or not in all of this, such as with interpretations of fossils and so forth, just because a person, whether evolutionist or creationist, might wish something to be true, or false, it doesn't make it so, no matter what convoluted fanciful ideas a person thinks up. Even if both opposing beliefs might be somewhat emotional to start with, that is, one born out of a so-called anti-religious predisposition and the other a more traditionally religious proclivity, on the face of it, it seems obvious which belief objectively agrees more with the empirical science, and which ideology subjectively disagrees with empirical observation of physical processes. For the origin of life, the implications of the evidence regarding the entropy principle look even more dire, for the notion of a naturalistic abiogenesis that might be assumed from materialist atheism. Theoretically, any single protein molecule, whether functional or non-functional, forming by chance in a hypothetical soup of amino acids is 1 in 10 to the power 65, theoretically the total number of all possible proteins being 10 to the power 65. It's like searching for one specific atom in our entire galaxy, the estimated total number of atoms in the galaxy roughly being anywhere from maybe 10 to the power 65 up to 10 to the power 68. More recently, some estimates for forming a single functional protein, approximately 150 amino acids long, by random chance is as low as 1 in 10 to the power 164. And yet another estimate from rigorous scientific research is, for every functional protein, there are 10 to the power 77 non-functional possibilities. That would be conservatively 1 billion Milky Way galaxies worth of atoms. To try and describe that number, according to the current scientific theories, over the entire 3.5 billion year history of life on Earth, only an estimated 10 to the power 40 individual organisms have ever lived. That's not enough time to make likely even one functional or non-functional protein spontaneously form, let alone a so-called simple life form. And of course it is now well known that even those forms of life are not simple at all, but vastly far from simple. Be it a cell or a virus, both of which are made out of multitudes of many, many different types of functional protein molecules, and also DNA, RNA, etc. Theistic evolution, a scientific, philosophical, and theological critique. J.P. Morland, Stephen C. Meyer, Christopher Shaw, and K. Geiger, Wayne Grudem. We must therefore dispense with irrationality, and the incredulity of abiogenesis or macroevolution, and indeed we must accept what proper empirical science has given us instead, especially when we view DNA and its symbolic code with some similarity of functionality to the words and letters in a book. To quote Sir Arthur Eddington, the practical measure of the random element which can increase in the universe but can never decrease is called entropy. Measuring by entropy is the same as measuring by the chance explained in the last paragraph, only the unimaginably large numbers are transformed, by a simple formula, into a more convenient scale of reckoning. Entropy continually increases. We can, by isolating parts of the world and postulating rather idealized conditions in our problems, arrest the increase, but we cannot turn it into a decrease. That would involve something much worse than a violation of an ordinary law of nature, namely, an improbable coincidence. The law that entropy always increases, the second law of thermodynamics, holds, I think, the supreme position among the laws of nature. If someone points out to you that your pet theory of the universe is in disagreement with Maxwell's equations, then so much the worse for Maxwell's equations. If it is found to be contradicted by observation, well, these experimentalists do bungle things sometimes. But if your theory is found to be against the second law of thermodynamics, I can give you no hope. There is nothing for it but to collapse in deepest humiliation. Eddington, A.S., The Nature of the Physical World, 1928, The Gifford Lectures, 1927, Cambridge University Press, Cambridge, UK, 1933, reprint. Pages 74-75. Emphasis original. Since that statement was written, our knowledge of biology and genetics has increased to the point where by extension we can legitimately say that there is nothing left for the pet theories of abiogenesis and macroevolution, but to collapse in deepest humiliation. If genetic code had not turned out to be a specified code at all, but all just random nonsense instead, then all the theological arguments might have collapsed, and the nihilist view of some existentialists would have become the dominant view, perhaps the only view, in today's world, and the ultimate human outlook would have been that of only futility, and no amount of light that we had shone in the darkest places of physical reality would have given us any lasting meaning or purpose. But as it turns out, the deeper science digs, the more it discovers about the remarkable sophistication of the world that we are all a part of. The biblical-based religious worldviews, whether you believe them to be true or false, are in agreement with these empirical arguments. But such a bleak outlook, the theoretical heat death of the universe or the gene death of all species, is not without hope. Even the famous Richard Feynman was compelled to ask, how did the thing get ordered in the first place? It's a good scientific question. And science alone might never be able to answer it. What makes this even more remarkable is that the question was asked at a time where the Big Bang theory had just begun to be more established in the scientific community and the steady-state theory was in its death throes, advocated by people like Fred Hoyle, who postulated that the universe had no beginning but had always been there from eternity past. But even without the idea of the universe having this kind of beginning that the Big Bang ascribes, the entropy law itself independently was pointing to the universe having a beginning of maximum order, maximum organization. One can logically see that if the universe were past eternal, it would have run out of energy and organization by now, actually an eternity ago, but we all can clearly see from our own personal experience that this has not happened. Even now, for those who find the concept of the Big Bang theory plausible, it looks highly obvious that the universe had to begin more ordered, which means that the existence of an intelligent creator seems to be far more probable than not, even if it makes no sense to us how this original organizer came to be. It's like in the well-known Sherlock Holmes stories, when you have eliminated all the impossibilities, then what remains, no matter how seemingly unlikely, must be the truth. Reasoning up from the most fundamental axioms that we are sure of, so far we might only conclude that the ultimate primary cause of everything is not subject to the laws of nature. This is the boundary condition that some people will not accept as reality because there can be no scientific explanation for it. So, although there is this so-called divine hiddenness, where we find ourselves living in this vast sea of demon-haunted darkness, we are able to shine our little science candle on at least some aspects of it and reveal certain truths. For those people who choose to take biblical doctrine as their axiom and put it to the test, we have an account where the Son of God said, "Heaven and earth will pass away, but my words will by no means pass away." Matthew 24:35, Luke 21:33, Mark 13:31. This statement seems to be a hyperbole because other scriptures show that heaven and earth will endure forever. So what was his point? Genesis 9:16, Psalms 104:5, Ecclesiastes 1:4. It might mean, at least in part, that whether the universe were in existence or not, God's laws or words remain forever, perhaps including the laws written into the universe. Even if the universe were to decay away to nothing, the laws themselves would still hold, as more fundamental. Ludwig Boltzmann, who lived from 1844 to 1906, is widely considered to have been an atheist or at least a non-religious, materialist thinker. However, he did not heavily publicize his private religious views, but he was able to statistically model the behavior of gas molecules and arrived at a mathematically undeniable conclusion. He discovered in his equations that dynamically ordered states are, as he put it, infinitely improbable. There are overwhelmingly many more possible disordered states in a system than possible orderly ones, and therefore a system will virtually always be found either moving towards disorder or in the state of maximum disorder. Why? Because it is statistically inevitable. Simply put, it is more than likely to happen. Depending on which system you are describing, another way of looking at it is, there are vastly more ways of something going wrong than there are of something going right, therefore if the system is left to itself, it will always go wrong over time. There are vastly more ways of something being disorganized than there are of something being organized, therefore if the system is left to nature, it will always become disorganized over time. There are vastly more ways of something being evenly mixed and spread out than there are of something being separated and lopsided, therefore if the system is left to itself, it will always go toward a maximum state of being completely mixed or spread out over time. But the fundamental idea of increasing randomness or a reductionist idealized potential maximum state of disorganization and randomness remains. because it is a condition of highest probability. Some people argue over the word disorder. Disorder, to describe entropy, is a subjective term, but in the context of physics it is referring to the state that the decay of a system will result in. The state of highest probability. For example, randomness, homogeneity, equilibrium, the lowest state of potential energy, or being spread out, dissipated or uniformly distributed, depending on the system being described. A.B. Pippard said, "There is thus no justification for the view, often glibly repeated, that the second law of thermodynamics is only statistically true, in the sense that microscopic violations repeatedly occur, but never violations of any serious magnitude. On the contrary, no evidence has ever been presented that the second law breaks down under any circumstances." A.B. Pippard. Elements of Chemical Thermodynamics for Advanced Students of Physics, 1986. Heat flows from hot to cold regions because the laws of probability favor a more uniform distribution of heat energy. Physicists sometimes postulate the unlikelihood of all the air molecules in a room all by accident coinciding in one side of the room where the other side is left with an empty vacuum, but this would be tantamount to a miracle, and naturalistic science cannot tolerate such a notion. You would have to wait for vastly longer than the age of the universe for this to happen by chance occurrences, which is a gross understatement beyond human comprehension. There is no 10 to the power of any negative number small enough that can be envisaged to describe such a ludicrously tiny probability. The thought experiment itself is not accurately representative of reality because atoms electromagnetically repel each other, and so the repulsive forces between the molecules would never allow such a thing to happen like that anyway. The situation is far more dynamic than described. Some physicists think that this indicates an even more fundamental level of reality. But for reductionism, repulsive forces are not included in the thought experiment to gain a more fundamental understanding of the basic underlying statistical principles involved. Some people imagine that with infinite time, and where the particles of the universe are limited or even unlimited in number, that this will allow at least a low probability where they are still bound to repeat their same arrangements an infinite amount of times, thus orders sometimes accidentally arising, and history will repeat itself forever. But nobody knows whether the universe is just made of only finite particles or not. Why does relativity theory not cooperate with quantum mechanics? There could be many aspects of the universe that are not only discrete but analog as well, in which case there might never be repetition. So there is more than one way to think about infinity, not just the amount of time or numbers of particles but also possible non-discrete aspects within the universe as well. But, for now, although it's fun to think about, such metaphysical speculation is for the philosophers. But do the mathematical principles of this second law only apply to atoms and molecules? No. E.S. Greens said, "It is a very broad and general law, and because its applications are so varied it may be stated in a great variety of ways." E.S. Greens. Principles of Physics 1982. Isaac Asimov said, "All of them are equivalent, although some very sophisticated mathematics and physics is involved in the showing the equivalence." Isaac Asimov, in The Game of Energy and Thermodynamics, You Can't Even Break Even, Journal of the Smithsonian Institute, June 1970. Entropy is a description of many parts interacting according to probability. It is by definition insufficient to describe it in terms of only one or two individual parts interacting, but instead, it is a description of an enormously complex outcome of probabilities that can usually only be rounded out into a convenient scale of reckoning. Fluctuation is a reversal but is not entropy reversal within any system but just part of the overall entropy principle of increasing randomness. Fluctuation and randomness in this way are usually the same. Do atheists and evolutionists ever ask, is it possible that everything we know of started out more organized? So far, the observable evidence agrees with this notion. Any possible theorized localized micro-reversals have never been observed to stop this from happening. Not even in biological systems. Surely if it were true, it seems likely that scientists would have seen it by now, but, despite some dubious claims, they have not. By this we are led to the logical conclusion that whatever the first cause of everything was, it must be a primary causation without a beginning, whether it be a natural past eternal process, or an infinite, past eternal, intelligent creator. This first cause argument would still hold even if you postulate that our experience of time is not real but only emergent. Nevertheless, in light of the entropy principle pointing to an organized beginning, the intelligent cause seems more plausible. In materialist terms, have we missed something? Because this then brings forth a logical paradox that the order had to suddenly appear at the start of everything. This is not what we understand to be natural. Scientifically we never observe complex things like biology beginning more ordered only due to less complex natural processes. It is logical to suggest therefore that whatever put this kind of order there, had to be something else even more ordered, beyond only unplanned undirected natural processes, perhaps some kind of organizing intelligence. By extension, there must be a past eternal or self-existent entity, perhaps that same entity intelligent, without a beginning, not subject to the entropy law, even if we can never understand how it might be possible. Is this where we reach the limits of science and human understanding? As uncomfortable as it might be from a materialist perspective, the scientific evidence points us in that paradoxical direction. Logic leads us to a seemingly illogical conclusion, but rationality demands that it be faced, and the only option left from here is an extrapolated leap of faith based on repeatable observations. And many scientists have begun to realize this, and for them, God is not just a religious metaphor anymore. Zoologist Edward Luther Kessel was an American biologist who was known for his work as an entomologist and his writings to reconcile science and religion. He reveals some interesting facts about a law of thermodynamics, the law of entropy as it is often called. In an article entitled, "Born to Believe in God," although it is difficult to find the original source, he is quoted by different people as saying, "The law of entropy states that there is a continuous flow of heat from warmer to colder bodies, and that this flow cannot be reversed to pass spontaneously in the opposite direction. Entropy is the ratio of unavailable to available energy, so that it may be said that the entropy of the universe is always increasing. Therefore the universe is headed for a time when the temperature will be universally uniform and there will be no more useful energy. Consequently there will be no more chemical and physical processes, and life itself will cease to exist. But because life is still going on, and chemical and physical processes are still in progress, it is evident that our universe could not have existed from eternity, else it would have long since run out of useful energy and ground to a halt. Therefore, quite unintentionally, science proves that our universe had a beginning. And in so doing it proves the reality of God, for whatever had a beginning did not begin of itself but demands a prime mover, a creator, a God. Even if this were a spurious quote, the statements therein are technically correct, and well argued. If you are familiar with the second law of thermodynamics, then you will understand the following logic. Even though someone of the atheistic persuasion might say that God demands a scientific explanation in his own right, from a scientific physics perspective we nonetheless all realize that there had to be a self-existent primed mover of some kind as the cause of everything, and it had to have been of a more organized existence. And materialists might imagine an organized physical existence, to start it all with. However, because the scientific evidence suggests that the primed mover had to be, not only self-existent but also, more ordered, and the most organized of all, more specified than anything that came after it, such self-existence cannot be physical. So saith the entropy law. The mistake that materialists make, is, demanding a physical explanation for a God who created the physical laws, for which there cannot, and never, be. For there is the origin of time, space, matter, and energy to consider. So, the physical evidence demonstrates the existence of something not seen, and not necessarily within the physical universe, and something that can only be non-physical, supernatural, powerful beyond measure, eternal or timeless, and incorruptible. You may as well call it God. So science points in that direction, but won't ever be able to fully explain it, and it is more than just a metaphor, something else is required. So faith is not from personal incredulity, but it is based on irrefutable observable evidence. This very biblical argument at Hebrews chapter 11 verse 3 states, "By faith we perceived that the systems of things were put in order by God's word, so that what is seen has come into existence from things that are not visible." The universe seems to point to something beyond itself. So, despite the limited scope of materialism, one might conclude, organized systems require an organizer, a mind, and, ultimately, a God.